We can improve the quality of our reporting by formatting the text of our reports. Unix shines here because it was initially conceived as a system to format documents. This was the use case its creators put forward in order to obtain internal funding for their hardware within Bell Laboratories. There are many tools that we can use, both traditional and more modern ones, and we will see both kinds in this unit. All tools are based on the concept of markup, the insertion of special marks within the text file in order to identify its structure and formatting. A very widely used markup format is HTML. This is the one we want to use if we want to serve the results as static web pages or to deliver them as formatted email messages. As an example, let's create an HTML file that outputs a random long dictionary word. This could be daily updated by a website to introduce less common words to its visitors. I write the HTML contents in a here document. First, I specify the tag doctype.html in angle brackets to define that this is an HTML document. The following HTML tag denotes the beginning of the HTML content. Within the head section, we specify the document's metadata. In this case, I only include one element, the title, today's word. Next comes the body section. This includes the actual content that the user will see. Here, I specify a heading 1, H1 element, today's word. Then, I include an HTML comment, pick a random long word. The comment explains the following command, which picks the random word from the dictionary. Specifically, I run grep on the words file to match lines containing a long sequence of dots, so arbitrary characters. Finally, I shuffle the output and select one word. As a result, we get a random long word. In the end, with /body we end the document's body section, while with /html we conclude the HTML content. This is the formatted HTML as it appears in a browser. Another versatile text markup format is Markdown. Its main advantage is that the source code of the markup text is also easily and intuitively readable as plain text. Let's see another example. Our task is to create a nice PDF document that will again introduce to its readers unusually long words. For this purpose, I create a Unix shell script in a here document. I enclose the commands that will generate the Markdown content in a pair of curly brackets, because I'll pipe their output to another command as we'll see. First, I write a level 1 header, learn long words. Note that in Markdown, level 1 headers start with a single hash sign. Then, I list all long words starting with A, B, and C. Of course, I could include the entire alphabet, but this is only a demonstration. Thus, I iterate over the first 3 characters, and in each iteration, I create a level 2 header separated by new lines. Similarly, level 2 headers start with a double hash sign. As you can see, I print starting with $i, where variable I is replaced by each character. Next, I need to select from the dictionary words starting with a particular character. To do that, I use the awk command with a $i pattern, which matches a line's beginning. For the matched lines, or actually the matched words, I print the line's length and content. Then, I sort the output lines by their length in reverse numerical order and select the 5 longest ones. Finally, using sed, I remove the length, note that this ends with a space, and prepend each output word with a bullet. This is specified by a star. After ending the Markdown content, I run a t command to save a copy of the file longwords.md. In the end, I pipe the output file to the pandoc command. This is a document converter. It takes as input a document of the specified format and converts it into another format. In this case, I convert from Markdown to PDF. By default, pandoc converts from Markdown to HTML, so -f Markdown could be omitted here. Moreover, pandoc can also figure out the input and output formats from the file name extensions. Note that in order to create a PDF document, you need to have LaTeX installed. Now, let's execute the script. Catenating the markdown file, we get the following result. As expected, there is a level 1 and 3 level 2 headers, along with the 5 longest words starting with A, B, and C, all preceded by a bullet.
This is the Markdown document formatted through Pandoc. Pandoc can use internally LaTeX to create nicely formatted documents. If we want to format source code in a nice way, then Pygmentize is a tool that can deal with scores of both programming languages and output formats.
For instance, let's format the script we wrote in the previous example. I run the Pygmentize command on longwords.sh, specifying that the output format I want to use is HTML, the input is Unix shell commands, the produced documents will have numbered lines, and lastly, that the output file name will be longwords.html.
This is how a file, a shell script in this case, formatted with Pygmentize, will appear in HTML. As you can see, built-in commands, reserved words, strings, and variable expansions are represented with different colors. For advanced scientific texts containing equations, footnotes, cross-references, and bibliographic references, LaTeX is the formatted and tool we want to use.
Let's now write a small LaTeX document step by step. The first line, \document class, specifies the document's type. Here I use the minimal class, but this could also be article, book, report, and so on. In LaTeX, larger sections are defined by begin and end blocks, while commands are preceded by a backslash. Therefore, I write \begin and specify that the block type is document. Next, I write the document's contents. These are fixed, but they could be produced by a program. Within \square brackets, we insert equations using common mathematical notation. For example, frac denotes a fraction, followed by the numerator and the denominator in 2 pairs of curly brackets. Furthermore, SQRT stands for square root, while up arrow specifies a superscript. We can also nest operations, as I do here with the denominator. Finally, with \end document, we end our document. Now, running PDF LaTeX on the base name of the input file formats it into a PDF document.
This is the text formatted with LaTeX. Notice how well it formatted the equation. The numbers in the denominator are smaller, they all fit neatly under the square root symbol, and the symbols are formatted in italic font. Unix traditionally uses TIROF as its text markup format and formatting tool. Nowadays, this format is mostly used for formatting the system's manual pages.
On the Unix system, the source markup of the manual pages is stored in compressed files under user share man. Here, I specify the man1 directory, which contains the user program's manual pages. I decompress one of its files, man1.gz, using the zcat command. As you may guess, this contains the manual page of the man command. Then, I pipe the output to fixed grep in order to remove all comments. In TIROF, these are specified by a backslash and a double quotation mark. TIROF formatting commands and macros are specified by a dot and a character sequence. Let's have a look at the first 20 lines of the man's manual page. First, the th macro specifies the manual's header, defines its name, the manual section, the date, and so on. Next, sh stands for section header. It contains the command's name and short description, an interface to the online reference manuals. Then, there is another section header with the command synopsis. Further on, we get more TIROF commands, starting with a dot, similar to the above ones. For example, B means bold, RB alternates between Roman and bold, and IR alternates between italics and Roman. As we can see, the syntax is not very user-friendly, and that's probably one reason TROF is not widely used. To typeset this document, after decompressing it, I pipe it to an open-source version of TROF called GROF. I specify as an argument the macros used in the file's formatting, which in this case are the man macros. Finally, I save the output in a PostScript format file, which many printers and typesets can process. Alternatively, we can run the man command specifying the -t option, which similarly formats the output using TROF. If we want to obtain the output in the more modern PDF format, we can do this with the command ps to PDF.
This is the man page of the man command rendered with GROF. As you can see, it uses various fonts such as bold and italic, as well as uppercase and justification in order to render the text in a pleasant printed format. True to the Unix philosophy of having one tool do one thing well, the TROF family of tools uses separate tools for different formatting tasks. Thus, in order to format tables, we use the TBL tool.
Let's create a table with character frequencies. First, I open a curly bracket to specify a command sequence that will create the markup required for this table. In a here document, I first specify the TROF command ts, which denotes the beginning of a table. TBL uses this to start its own processing. Then, I specify how the table items will be processed. Particularly, AllBox encloses each table item in a box, while tab of @ specifies that the @ sign will be used as a column separator. With CS, I center the table's title, which is character frequencies, and span it to 2 columns. Then, LN left aligns the items of the first column and numerically justifies the second. These will contain the characters and their frequencies respectively. After ending the here document, it's time to process the actual file. Let's use our familiar Pride and Prejudice novel. Running sed on it, I substitute each dot, so any character, with a new line, so that each character appears on a separate line. Next, I sort the characters, count their frequencies with unique -c, and sort them in reverse numerical order as usual. Then, I pipe the output to awk in order to print the characters in the first column and the frequencies in the second. These are separated by an @ sign, which is the column separator that TBL will use, as specified above. Finally, I select the 10 most frequent characters to display. At the end, I echo TE for table end and end the command sequence with a close curly bracket. Piping the output to the T program, I save a copy in the file wordfreq.nr. The nr suffix stands for nrof, new rof. In case you're confused, let's summarize the 3 rof programs we introduced. trof is designed for typesetting quality output, whereas nrof formats output for line printers and character terminals. Except for some functions that are specific to trof, the same commands apply to both programs. Furthermore, grof is an open source version of these two. Now back to our example. I pipe the output nrof file to the tbl command in order to format the table. Lastly, the formatted table is saved in a PostScript file through the grof command. Looking now into the wordfreq.nr file, we see that it contains the table start and end commands, the formatting instructions, as well as the first 10 characters and their frequencies.
This is a table generated by TBL and trof. Similarly to the approach of TBL, if we want to format equations, we can use the EQN tool to process them in a special markup format and then pass down the result to trof.
To see an example, I run EQN on a trof document. First, I specify an actual trof text. The height of a curve with a standard deviation of sigma is given by. Then, I use the EQ command to denote the beginning of an EQN block. This allows me to write an equation using special notation such as over, sqrt, sigma and curly brackets to represent common mathematical operations and their nesting. Finally, I end the equation with en and the here document with EOF. In the end, I pipe the output to GROF, asking it to generate a PostScript document and save the result in a file named equation.ps.
This is the markup formatted with EQN and TROF. As you can see, the result is not as good as that of LaTeX. For example, the square root symbol should be a bit larger and extend further to the right. This concludes our unit on text formatting reports. Stay with us.